Good day, freshmen. Welcome to Eastern Visayas State University. I hope that you are enjoying your stay here with us. In this video, we are going to tackle how to graph a function. This is a continuation of your discussion on domain and range of a function with Engineer Cidro. Are you ready? So without further ado, let's start with the objectives. After watching this video, you are expected to be able to identify the type of a given function, review on finding the roots of a polynomial function, and create a graph of a given function. But how important graphing a function is? As important as we know how to convert data into function or equation, it is also important to know how to graph a function for easier analysis of data. As watchers or readers, it would be very pleasing to the eyes if we can see the visual interpretation of data. Furthermore, this topic is necessary to the next chapters of this course. The most basic steps in sketching the graph may be followed depending on the type of a given function and the properties that one may wanted to know. Every function of y is equal to f of x has a unique graph in the rectangular coordinate system. For instance, the most basic function that you may be familiar with is the linear function. What is a characteristic of a linear function? A linear function must consist of a variable with exponent of 1. For example, we are tasked to sketch the graph of y is equals to 3x minus 2. What is the first step that we need to do? Yes, we have to tabulate values of x and y to acquire coordinates. If we substitute x to the value of 0, y is equal to negative 2. If x equal to 1, y is equals to 1. If x is equal to 2, y is equals to 4. Then, we proceed to locating the coordinates in our xy plane. We have the coordinates 0, negative 2, 1, 1, and 2, 4. Next, we connect the dots with a smooth line. That is the graph of the function y is equals to 3x minus 2. Moving on to our next type of function, we have now polynomial function. But what is a polynomial function? The polynomial function is such that all terms in f of x contains x with whole number exponents 0, 1, 2, and so on. We can write a polynomial function in the form f of x equals to x raised to 0 plus x raised to 1 plus x raised to 2 and so on. What if I put coefficients before the variables x? Is it still a polynomial function? Yes, it is. But what if I write this one? Is it a polynomial function? No. This is called non-polynomial function. Why? Because it consists of terms where variables have negative and fraction exponents. This function could be written in the form, and this is a fractional form. And this one could also be written as, and this is in radical form. Another description of a polynomial function is if there is no x in the denominator or in the radicand. This is an example of a graph of a polynomial function. Let us follow these steps to sketch the graph of a polynomial function. First, we have to find the intercepts. You locate the points of intersection of the graph with the y-axis and x-axis obtained by respectively assigning x is equals to 0 and y is equals to 0. Then, we have to find the behavior of x for large values of x. We determine the direction of the left tail and right tail of the graph by observing the behavior of y when x is assigned by large negative and large positive values. Then, we find the location of the graph. We determine the location of the graph between x-intercepts, whether it lies below or above the x-axis, by determining the sign of y when x is assigned to a value between intercepts. Lastly, we join the plotted points. If necessary, construct a table of values for additional points. Plot all the known points in the rectangular coordinate system. Join the plotted points in the plane with a straight line or smooth curve. Let's try to graph the given polynomial function. Let us go back to our steps. First step is finding the intercepts. Starting with the x-intercept, set y is equals to 0. We have 0 is equals to negative x cubed plus 2x squared plus 11x minus 12. Isn't this familiar? The next step is now to find the roots. But how? You have known from your previous mathematics that there are several ways in finding the roots of a polynomial. If not yet, I suggest to have a review first on the link provided in the description box below. The video is my personal pick, one of my favorite channels in YouTube. Going back, it is said to have the following process in finding roots. So first is to factor common terms. Looking at our equation, can we factor common term? No. Then, next is to factor by GCF. Again, try to observe our equation. Can we have greatest common factor in every terms? No. So the remaining process we have is the rational zero theorem. But in this process, we have to list the values that if we substitute to x will give 0. How? We need to find the GCF for the constant term or x raised to 0. In this equation, that is negative 12. The factor for 12 are... Note that we did not include the negative sign because we may put negative on each of these numbers and multiply the positive number to have a negative product. But we know that at least one of the roots of this equation is negative. Let us first try to substitute 1 to x. This would give us an answer of 0. Hence, 1 is a factor. So we proceed to synthetic division with a factor of 1. So we have this. We just put the coefficients of the function to the upper portion of our synthetic division bar. Then, we put the factor 1 outside of the line. First step for synthetic division, we bring down negative 1. We multiply then 1 times negative 1, which is equal to negative 1. Then we add these values. 2 plus negative 1 is 1. Then we now multiply 1 times 1, that is 1. Then we add 11 plus 1. Is equals to 12. Then we multiply 12 times 1, which is equals to 12. Then we add negative 12 plus 12, that is equal to 0. This is a better sign that we are doing this job right. We now have a binomial equation. Factoring a binomial equation seems easy compared to trinomial equation. So we now have... Note that this one is the factor that we've got from our 1. Then this one is the binomial equation that we've got after the synthetic division. Factoring, we get, by zero product property, we have values of x as x equals to 1, x equals to 4, and x equals to -3. In coordinates, these are 1, 0, 4, 0, and -3, 0. Now we plot the coordinates in our xy plane. We now proceed with our y-intercepts. We set the value of x equal to 0. So we've now got, then y is equal to -12. In coordinates, we have 0 and -12. Again, we have to plot this one in our coordinate plane. So that is 0, -12. We now proceed to the next step, that is the behavior of y for large values of x. So how do we do this one? So when x approaches to -infinity, y approaches to +infinity. But how? We just assign large negative values to our x. So to start with, we have -500. So that is equal to a positive number. Therefore, when x approaches to -infinity, y approaches to +infinity. Whereas, when x approaches to +infinity, y approaches to -infinity. Here's the proof. Note that our 500 is our assumption or our assigned large positive value. Then y is equal to negative large value. Therefore, it is y approaches to -infinity. Or we could say that when x approaches to +infinity, y approaches to -infinity. How to sketch this one? Note that in this procedure, we have to determine the direction of the left tail and right tail of the graph. So let us now plot this one. So again, when x approaches to -infinity, y approaches to +infinity, or that one. So as it moves to the negative horizontal axis, it approaches to positive vertical axis. So on the other hand, when x approaches to positive x-axis, it approaches to negative y-axis. So that's how we draw that one. Before we proceed to the next step, please note these 3 coordinates. They are our x-intercepts. So for the next step, we have to find the location of the graph between x-intercepts, whether it lies below or above the x-axis. So let us proceed. Note that we have the first limit where x is greater than -3 but is less than 1. So what are the values between these values? Yes, we have -2, 0, and -1. So let's say x equals to -2. By substitution, we get, note that we use the factored form. Then y is equal to a negative value, hence the curve lies below the x-axis. Then we proceed to the next limits. When x is less than 4 but is greater than 1. Say x equals to 2. Again, we could use the value of 3. So for this one, we'll be using x equals to 2. By substitution, we get, therefore y is equal to a positive value. Hence, the curve lies above the x-axis. So how do we draw this one? So note that in this step, we have to find the curve which lies between these coordinates and between these coordinates. So we know that between these coordinates, our y is a negative value. So the curve lies below the x-axis. And between these coordinates, our y is a positive value. Hence, the curve lies above the x-axis. So now we'll draw a smooth curve. And that's how you'd sketch the graph of y equals negative x cubed plus 2x squared plus 11x minus 12. We then proceed to the next type of function, the rational function. What is a rational function? A fraction with a polynomial numerator and a polynomial denominator is called a rational function, whereas an irrational function is a function which contains a variable in the radical. So a rational function can be written in the form. Let's try to have an example of what rational function looks like. So this is an example of a rational function. Let's follow the steps in graphing a rational function. First is to determine the symmetry. If all the terms in the numerator and denominator has even exponents of x, the graph is symmetric with respect to the y-axis. If all the terms in the numerator and denominator has odd exponents of x, the graph is symmetric with respect to the origin. Then we proceed to the next step. We find the intercepts. Locate the points of intersection of the graph with the y-axis and x-axis, obtained by respectively assigning x equals to 0 and y is equals to 0. Then, we determine the vertical and horizontal asymptote. Determine the vertical asymptote by solving for x when y approaches to infinity, and the horizontal asymptote by solving for y when x approaches to infinity. Then we determine the location of the graph. Determine the location of the graph between x-intercepts and vertical asymptotes. If y is less than 0, the graph lies below the x-axis. If y is greater than 0, the graph lies above the x-axis. Then we join the plotted points. So if necessary, construct a table of values for additional points. Plot all the known points in the rectangular coordinate system. Join the plotted points in the plane with a smooth curve. So we try to graph a rational function with the given example. So y is equals to x minus 4 over x squared minus 1. So given the first step, which is to determine the symmetry, so in this step, we have to observe the exponents of the variable x in the numerator and the exponent of the variable x in our denominator. After careful examination on the exponents of the numerator and the exponents of the denominator, we could say that the exponents of x is neither all even nor all odd. Therefore, there is no symmetry with respect to y-axis nor with the origin. So for the numerator, we have an odd exponent, and the denominator, we have even exponent. So we then proceed to the next step. We find the intercepts. So first, the x-intercepts, we set y is equals to 0. That's it. Then by cross multiplication, we've got 0 is equals to x minus 4. Therefore, x is equals to 4. Next is the y-intercept. Set x equals to 0. We get, therefore, y is equals to 4. In coordinates, we have 4, 0, 0, 4. Let us now plot our coordinates. So again, we have 4, 0, and 0, 4. Assuming that one division is equals to 5 units. Then we proceed to the next step, which is to determine the vertical and horizontal asymptote. We now find first the vertical asymptote. So let y approaches the positive or negative infinity. So as y approaches to infinity, we have, by cross multiplication, we will get, therefore we have x squared minus 1 is equals to 0. So finding the roots of x squared minus 1, we have, recall the curve gets nearer into the asymptotes. Then we have the horizontal asymptotes. Divide each term in the numerator and denominator of the right-hand member by the x term of highest degree. For this function, we have 2 as the highest degree. So we have to divide each term with the term of the highest degree. So we now have, then we'll let x approaches the positive or negative infinity. So as x approaches to infinity, we have this one. And that concludes y is equals to 0. Or the x-axis. Okay, next, we find the intersection with the horizontal asymptote. We substitute y is equals to 1 in the given equation of the function. So y is equals to 1. Therefore, 1 is equals to x minus 4, x squared minus 1. Again, by cross multiplication, x squared minus 1 times 1 is x squared minus 1. Then, x squared minus 4. So, simplifying, we have x squared minus x plus 3 is equals to 0. Since we can't find our rational roots for this equation, we can say that the graph does not intersect the horizontal asymptote. Therefore, sketching the asymptotes, we have when x equals to 1 and x equals to negative 1 and y is equals to 0 or the x-axis. So note our vertical asymptotes and our x and y intercepts. Take note of this one before we proceed to our next step. So our next step is determining the location of the graph. So determine the location of the graph between x-intercepts and vertical asymptotes. If y is less than 0, the graph lies below the x-axis. If y is greater than 0, the graph lies above the x-axis. So when x is less than negative 1, say x is equal to negative 3. So when x is negative 3, this gives us a value of a negative digit. And for the denominator, negative 3 squared minus 1, that is a positive value. So negative over positive results to a negative value. So y is a negative value. So since y is less than 0, the graph lies below the x-axis. Then when x is less than 1 but is greater than negative 1, say x is equals to 0. When x equals to 0, the numerator results to a negative value and the denominator results to a negative value. When we divide two negative values, we get a quotient of a positive value. Hence, the graph lies above the x-axis. Then, when x is less than 4 but is greater than positive 1, let's say a value of x equals to 2, so we have y with a numerator of a negative value. So when x equals to 2, 2 minus 4, that is negative value. Then when x equals to 2, the denominator is 2 squared minus 1 is a positive value. So dividing negative by a positive value, we've got a negative value. Hence, the graph lies below the x-axis. When x is greater than 4, say x is equals to 5. So we say 5 minus 4 and 5 squared minus 1. So x is positive, and for the denominator, it is also positive. So a quotient of both positive terms is positive value. Therefore, the graph lies above the x-axis. So how do we draw based on this behavior? So between the vertical asymptotes of negative 1 and 1, we have the curve. Since it says that the graph lies above the x-axis. The value of x less than 4 but is greater than 1, the graph lies below the x-axis. However, from 4 onwards, the graph lies above the x-axis. It looks like this. When x is less than negative 1, it says that the graph lies below the x-axis. This is how you sketch the graph of the function y is equals to x minus 4 over x squared minus 1. Lastly, we have to graph a second-degree function. The equation y is equals ax squared plus bx plus c is a special case of a polynomial function, where instead of following the steps previously discussed, we can immediately tell the graph of the function is a parabola opening either upward or downward. So here is an example of a second-degree function. The exact behavior of the parabola can easily be determined following these steps. So we first find the vertex of the parabola. So locate the vertex of the parabola V, HK. This is point V, or the vertex, and this is its coordinate, where h is equals to negative b over 2a and k is equals to 4ac minus b squared over 4a. Then, we connect the points. Of course, we have to add points and connect with a smooth curve. Remember that it is symmetric with respect to the vertical line passing through the vertex. If a is less than 0, the parabola opens downward. If a is greater than 0, the parabola opens upward. So we now try to sketch the graph of y is equals to negative 2x squared plus 8x plus 5. So note that this is a second-degree function because its variable x has number 2 exponent. We now try to locate the vertex by the formula h is equals to negative b over 2a. For the constant a and b, your a is this one, your b is this one, and this is your c. So b is 8, and of course it's negative. Your 2 and your a is negative 2. So simplifying, we get h is equals to 2. Then we proceed with the value of k. K is equals to 4ac minus b squared over 4a. Again, your negative 2 is your a, your 8 is your b, your 5 is your c. So substituting the values, we have 4 times negative 2 times 5 minus 8 squared over 4 quantity negative 2. So simplifying, k is equals to 3. Therefore, we've got the coordinate of the vertex, which is 2, 13. So we now plot the vertex. So assuming again that our division is equal to 5 units, we have so that is our vertex. We then now proceed to our second and last step. So we connect the points. However, we still have to add points before connecting a smooth curve. Okay, so we then now proceed with additional points. We tabulate the values of x and y. When x equals to 0, that is 5. When x equals to 3, that is 11. 3 is a random number we picked up. It could be 2, it could be 4, 5, and so on. So with these values, we have coordinates 0, 5, and 3, 11. Note that a parabola is symmetric from its vertex. So whatever the curve here is the same as the curve here. So if a is less than 0, the curve opens downward. But when a is greater than 0, the curve opens upward. We plot first the coordinates that we get, that is 0, 5, and 3, 11. Then we now connect the dots and draw a smooth curve. That is how to sketch the graph of y is equals negative 2x squared plus 8x plus 5. And that ends our discussion for today. I hope you have learned how to graph a given function. See you on the next topic. This work has been made possible with the following people: Dr. Maria Lea Ayabad, Engineer Rina Marie V. Pedrosa, Engineer Mark Kevin T. Cidro, Engineer Lalaine Jean Balyaes, and Engineer Romeo Gibao Jr. For queries, comments, suggestions, feel free to email me at rjane.lacambra@evsu.edu.ph. Thank you and God bless.